Alright, you guys, so now that we have some zero theory, if you would, right, so what it means to be a zero and the equivalent statements we can make, another thing about zeros is what we call their multiplicity. Basically, this is defined as the number of times the zero, or the factor x minus c, occurs in the factorization of the polynomial. So let's just cut to an example, right? So if we looked at the polynomial p of x equals x squared minus 10x plus 25, and if we used our factoring skills, we will find that the factor x minus 5 occurs twice. So using our theory, this means that x equals to 5 is a 0, right? This means that p of 5 is 0. This means that 5 of 0 is an x-intercept, alright, and it means that x minus 5 is a factor, and it occurs twice, and that is our multiplicity. So 5 is a 0 of multiplicity 2, right? If I wanted something to be multiplicity 3, then I would say x minus 5 to the third. If I want it to be, so this would be, we would say that 5 has a multiplicity of 3. If I wanted it to be a multiplicity of 4, then that factor would occur 4 times. Of course, what I'm doing by increasing the number of factors is I'm also increasing the degree. So we go from multiplicity 1, which means I'm a line, to multiplicity 2, which means I'm a parabola. Multiplicity 3 would make this a cubic, and then multiplicity 4 would make this a 4 degree. So by increasing that, we're increasing the number of terms, and hence increasing the number of the polynomial, the degree of the polynomial. We're increasing that, increasing a whole bunch of other things along with it. All right. So now that we know what multiplicity is, let's go ahead and take a closer look at it in terms of its graphical features. So because it turns out that looking at a graph, just like we did here, I can see what the multiplicity is just by looking at the graph. So what we're going to do is we're going to investigate with p of x equals to x minus 2. And so at x minus 2, right, when n is equal to 1, that means that we have a multiplicity of 1. And so what does that graph look like? Well, let's go ahead and turn my calculator on. Let me clear that, right, and let's just look at x minus 2. Alright, and what that basically does is it goes through, right, x equals to 2, and no surprise, it's behaving like a line. So it actually crosses the x-axis at 2, right, in a linear fashion, because our multiplicity is 1. Now, let me go ahead and do this too. I'm going to change my window. Since we're concentrating on 2, how about I go to from negative 5 to 5, so we can just really concentrate on that behavior there. Alright, so here's the graph. So here's x equals to 2, and we see that the graph is basically behaving, right, like a line. Now if I let n equal to 2, and we talk about x squared, right, now what I have is I have the same 0, I have the same x-intercept, but this time what is happening is that we are a degree 2 polynomial. You guys know to be that a quadratic. So let's see what happens there. So let's go to y equals. Let me turn that. I'm going to keep it in my calculator, but turn it off so it doesn't graph. And then let's go parentheses x minus 2, and this time we're going to square it to the second power. So when I go graph it, we're expecting a parabola, and of course what you notice is that parabola is basically kissing or touching the graph right at where we expected it, 2, 0. As a matter of fact, using other stuff we've learned, we know that it's taking our x squared graph and shifting it over twice. All right, so we've got that. So here, right, we're crossing the x-axis, and here we are touching it. All right, so let's go to n equals to 3. What if my multiplicity is 3? Well, again, you can expect a cubic graph being shifted over to the right, but let's just go ahead and see that. So let me turn that off, and I got some glare in there. All right, I want to keep this function on, but I don't want to graph it. And how about in y3 we put x minus 2, and this time we're going to raise to the third power. So what's the graph look like? Well, at 2, it behaves like a cubic. All right, that's what a classic cubic graph looks like. So it's not a line anymore, but it's got a little wrinkle in, if you would, a concavity, right? We go from concave down to concave up in terms of the shape of the graph, but we are actually crossing the graph. Here we're crossing the graph like a line, and here we're crossing it like a cubic. All right, but we are crossing the line. So what about n equals to 4? Right? What if we considered x minus 2 to the 4th power? What kind of behavior would we expect? All right, so let's see. Hopefully you're kind of guessing at home. Let me go ahead and turn that off and put in x minus 2, and this time we're going to raise to the 4th power. Right? And so when I go graph that, right, what you'll notice is that it behaves very much like a quadratic. It's kind of hard to see because we're so zoomed out, but it's just barely, again, it's just touching, right, the x-axis. It's still behaving like a parabola, but it is getting a little flatter. And if you continue on, right, if we looked at x minus 2 to the 5th, and x minus 2 to the 6th, and x minus 2 to the 7th, and x minus 2 to the 8th, if you kind of see a pattern, it looks like if we are an odd multiplicity, we are in fact actually crossing the x-axis at that location. And if we're an even multiplicity, then we are basically just touching the graph. And what's different though is how we're touching it. So let's just go ahead and investigate. Let's go ahead and investigate the even ones first. So let me go to my y, and let's just how about I change this to x minus 2 squared. All right, and we'll change this to 4, because I want to do even powers, right? So multiplicity of 4, multiplicity of 6, and multiplicity of 8. That should be enough right there. Okay, and so when I go graph this, what I'm also going to do, so we can see this, I'm going to go to my window again, and how about I zoom y? We'll go to -5 to 5. Just make it a little closer. So there's x squared, right? So parabola. Here's x to the 4th coming up. Here's x to the 6th coming up. And here's x to the 8th coming up. And so you'll notice that they're behaving very parabolically, but what's happening at each shape is the curve down here isn't as pronounced. As x squared, we have a nice curve, but as we increase the multiplicity, we're still touching, but it's kind of, how should I say it, it's kind of almost compressing right around the 0. And to see that a little bit more, how about we, I'll just zoom in. Let's go zoom in at that 0 and kind of see that action again. So there's about 2. So here's x squared, just glancing off of it, and then notice that x to the 4th, right, gets a little flatter, but it's still touching. X to the 6th is flatter, but still touching, and then x to the 8th is flatter and still touching. So x to the 10th would also behave parabolic, but it would kind of flatten out more, touch the graph, and then keep going up. So you can kind of see each graph is getting flatter and flatter. It's not a true compression as we understood it, but it is getting flatter right around that area. So that is what happens with even multiplicities. It touches the graph and gets flatter as we increase the multiplicity. So what about the cubic? So let's go ahead and raise this to the 1st power, right, a line. Let's raise this to a 3rd power, and let's raise this to a 5th power, and let's raise this to a 7th power. All right, and what you're going to expect, right, is we're going to be crossing the x-axis, but just like we saw with the increasing multiplicity, it kind of gets flat around the area of concern. So let's go ahead. How about I'm going to go back to the window, and let's make this -5 to 5 and -5 to 5. So let's kind of start looking at that. So here's the line. It crosses like a line. Here's the cubic, so it's crossing as a cubic. Here's the 5th degree, and here's the 7th degree. So notice it's still crossing, but it's getting a little bit flatter. So if we keep increasing the multiplicity, the graph kind of flattens out at that area of interest, in this case the x-intercept at x equals to 2, but the graph in general continues to behave like a line. It's still on its way up. The end behavior, right? Going to infinity, going to negative infinity in the other direction. Alright, and so that is how we can look at multiplicity on a graph. Of course, what that's also going to help us do is this kind of stuff. And that's what we're going to get to in the next part of our video. See you guys then.